the third lecture of the Introduction to Programming course. For today's lecture, we are going to be looking at some Git, so just a very high-level overview of what Git does and how it works and how to use it. After that, we will pull the latest notebooks from GitHub and then start working through those. So we'll start with the bit we missed out last week, and then we'll get into some new content after that. So the first thing is, what is Git? So Git is called version control software. There are many different types of version control software. Git is one of the most commonly used. It was invented by the creator of Linux, I believe, and he created it after getting into a disagreement with a company that makes some other types of version control software. So what this does is it will keep track of changes within a directory, and it always works from a root base directory. So try and make sure that you don't add Git to the wrong directory, because then it'll try tracking everything in your hard drive depending where you put it. Something else that Git does is it allows multiple people to work on the same project. So we'll discuss how this works a bit later on in the slides with a few demonstrations of how that could work. So the first thing to think about is, how would you track changes without something like version control? So I am guilty of doing this in the past, and basically you had a file you were working on, it has some content in it, and then as time goes on, you keep saving your file as different versions. These will generally get larger and larger as time goes on, and you have multiple versions. So all of these contain most of the same content with slight changes here and there. Something that could happen with this is, say we were working on a network drive and we were both had the same file open, and we made changes to the same line. What happens then is one person will save and the other person will save over that save. So this is not very conducive. It's not a good way of working. It's not a good way of working with collaborators. So version control sorts this out to allow collaborators to work in the same project. So how Git does this is, when you first create your file, there have been no save. It hasn't tracked anything yet. So the entire file that you have up until this point gets saved. So this bit of code here has a list, and it goes through the numbers from 0 to 19, and all the even numbers get added to the list. Don't need to worry too much about that. And once it's done, it prints the results. But what happens if, instead of looking for even numbers, we wanted to look for odd numbers? So we changed this line of code to instead look at odd numbers. So now, because Git is tracking all these lines of code, it only needs to keep track of the change that was made to go from the original file to the new version. And this is done on a line-by-line basis. So what this means is it will delete the original line, and it will then add this new line. So these are the changes that need to be made to the original version to become the new version. So that's what Git does. It's just a chain of these changes to go from one version of a file to another version. So there are 4 different states a file can be in a repository. The first state is untracked. What this means is that Git is not going to keep track of any changes to this file. And by default, when you create a new file, it will be untracked until you tell Git to start tracking it. So the way you tell Git to start tracking a file is that you add the file. And once the file has been added, it gets moved to this staged type, so state. And what the stage state is it just means that we have told Git that we would like to make a checkpoint with this file at this point in time with these changes. Once the file's changed, we can commit the file. So that's another action. And what committing will do is it will basically save a checkpoint of this file in the current state that it is, and this file type will now be unmodified. So that means that there are currently no changes to the file from the last time there was a commit. If we then make a change to an unmodified file, its type will become modified. So this means that this file has had some changes from the last commit, so it differs from the commit. And if we wanted to save another checkpoint, we would then stage the file by adding it again and then commit to save a checkpoint. So the different steps that we have here is add. Add will either add an untracked file to the staged staging section, or add will add a modified file to the staging section. So add does those two steps. And then the other step we're doing is committing. And what commit does is it takes all of our stage changes and it saves a checkpoint of what those files look like, and they will all then become unmodified type files. So the first thing that we're going to do is I'm just going to quickly run through the workflow of how to create a new project in VS Code, how we would initialize Git, how we would add a text file and keep track of it in VS Code. Then I will cover linking this project to GitHub, and then we will push the changes from our local computer to GitHub, and we'll make some changes on GitHub, pull those changes back into Visual Studio Code. So this would be simulating a collaborator working on the same project as you. And finally, we'll make a new branch so that we can see how branches work in a high-level overview. So for now, don't try following along with this. Just go over the video again afterwards if you want to. Otherwise, it's going to take a bit too long. So over here, some of these steps have to happen in different places. So creating a project we can do in VS Code. Initializing Git can be done in VS Code. Tracking changes and things like that can be done in VS Code. Linking to GitHub, you have to firstly create the repository on GitHub, and you have to link it using the terminal. You can't use VS Code for that step. Pushing changes to GitHub, your first push also needs to be from the terminal. Once you've done this once, you will then always be able to use VS Code to do this. Making changes on GitHub will be on the web. Pulling changes you can always do from VS Code, and making a new branch, we will do that on GitHub, and then we'll pull it into VS Code. So something to be aware of is that all of these commands that we're doing in VS Code can also be done in the terminal. Later on in the slides, I'm going to be giving the terminal instructions on how to do this. It's pretty interchangeable. So let's get started. So the first thing we're going to do is create a project in VS Code. So currently I've got our repository for the class. I'm going to open a new folder. So select open folder. I'm going to go to my desktop in the ITP directory, and I'm going to make a new folder called Git Demo. I cannot select this because of the, okay, so let's go there, okay, open. Okay, so now we've just made a new blank project in Visual Studio Code. Currently, nothing's being tracked. This is just an empty project. So the first thing that we can do is if we click on the left here on these three dots that are linked, this is our source control tab. It will now give us the option to initialize this repository. So what this just means is it's going to initialize a Git repository for this project. If we click on that, what actually happens is if we print the contents of this directory now, ls-a means show all files. You'll see that this has created a .git folder. So this is how Git works. It has a folder that has all the information it needs to keep track of your project. So initializing a repository just creates this folder within our project. If we go back to our project browser, we can make a new file, and I'm just going to call this readme.md. So GitHub likes having a readme.md. This will always be the default page that opens, and it gives a description of your project. So this is a markdown file. A # means this is a heading. So we'll call this project heading. Just listen for now. Do this on your own later. I'm just quickly going over all these steps, and it'll be in the video. And then we can add some content in VS Code. Okay, So basically this file is going to have a heading called that says project heading, and then another line that says some content in VS Code. So as soon as we save this file and we go to our version control tab, you'll see here that there are changes in this file, and this U over here means that this file is untracked. So that's from the previous slide where we saw that there were untracked files. So what we can do is click this plus here, and this will then stage the changes. So this is adding this file to our staging area. So now that we've added the file, you can see that it's actually in the staged area at this point in time. And the next thing we can do is commit. So in VS Code, you click this tick at the top to commit your changes. So this will then save a snapshot of how this file looks at this point in time. When you commit, you need to input a message. For the first, generally this message should be descriptive of what's happening. For your first commit, it's fairly common to say initial commit as the message. And then, well, okay. This is just due to my security things. Okay, so now this commit will be made, and you'll see that there are now no changes in this repository at this point in time. If we add a second line and we save this, now we have some more changes to our file. But now, instead of saying untracked, this is now modified. So it's telling us this file has been modified. Once again, we can stage the changes to move it to the staging area, and we can commit to save what the file looks like now. So we can just say small changes. And now this version of this file is saved, and we can then go back to the previous version if we wanted to and do some other things. So the next thing we're going to do is we are going to link this project on GitHub. So the way we do that is in your browser, you would go to GitHub, make sure you signed in, and then on the left here, you would click New Repository. So this brings up the options for creating a new repository. So we will call this ITP demo. The tick means that we have not made a repository that's called this. The owner, if you're part of groups, you can change what group this project's going to be made in. Description is just a brief description of the project that'll be shown at the top. We can ignore that for now. Public and private are the two types of repositories. Public means that anyone will be able to view your code, but you can still have to choose who can make changes to it. Private, on the other hand, only you and people you specify can see this code. So if you're working on an open source project, you'd probably want it to be public. If you are making something new and you want it to be either monetized or something down the line, you'd probably want that to be a private project. So now these last options you don't need to change, but let's just go over them. So the first is to create a README file for this repository. We don't need to do this because we've already done that. Something else is we can make a git ignore file. This is just a file that tells Git what folders and file types to ignore, and we can add a license. So licensing your projects is very important if other people are going to use them. Don't think we're going to cover that in this course, but it is worthwhile reading up on licensing. It's very necessary if you're making open source projects. Something else with this is .gitignore. Because it starts with the dot, this file will be hidden by default. So if you go to this in your regular file browser, you will probably not see this file, but if you are in VS Code, it will show you a gitignore file. Let's add one of those so that we can see what this will do. So these are all the different programming languages we can generate an automatic one for. We'll just select Python and we'll create this repository. Doing this was actually not a very good idea. I'm going to start over from scratch, actually, because the reason I'm saying that is this gives you instructions if you have nothing in your repository. Maybe I can, no, I'm just going to start over. So new, call this ITP demo 2, and I'm just going to create this. Saving changes would be Control S on Windows and Command S on Mac. You can also set it up that whenever you change the file, it automatically saves. You do that in your settings. Okay, so when we've made a new repository, something to keep in mind is there are two ways that you can link to this repository. I have to use SSH because of security things I've set up. You would generally want to use HTTPS. So just changing this will change the commands that you need to do. So I'm going to keep it on SSH. If you're doing this, make sure that it's on HTTPS. So it gives you two sets of instructions. The first set of instructions is what you should do if you are making a brand new directory that hasn't been initialized yet. So we initialized our directory and added a README in VS Code, so we need to follow the second set of instructions. So what these are doing is it's basically telling Git where our remote repository is, and it's calling this repository origin. So it's adding a remote repository called origin, and that's the URL for it. And the next step is that it's taking the current master branch on our local repository and pushing it upstream to master. So the first thing we'll do is link our remote to our other repository. So you'd have to do this in the terminal. So if we paste this command in, we can now add our remote, and doing this doesn't actually do anything. What will change is this little icon will appear saying that we want to publish our changes. So we have two options at this point. The one is we could follow this step to publish our changes. The other is that we could click this button to publish our changes. So I'm just going to do the type command. So what this is currently going to do is it's going to push our master branch upstream to GitHub. So when we push enter, it'll now tell us what's going on. So this is going over all the objects in our project. It's compressing things. It's then writing these online, and it's telling us that on GitHub, it has created a new branch called master, and that our local master branch is pointing to the remote master branch. At this stage, if we type git status, it's going to tell us that our branch is up to date with the remote branch. So that means that our branches are now correctly linked together. And if we go back to GitHub and we refresh this page, you will now see that we have our README file from our local VS Code. So with project heading and some content in VS Code. And the second line, Markdown formats in a strange way. So separate lines actually get joined together unless there's a double blank line in between them. So now our project is set up to track changes from GitHub online. So what we can do now is if we edit this file in GitHub, so let's add another line at the end of this saying a line on GitHub. And we can then commit this. I'm just for now going to commit this directly to our master branch. So we commit this change. And now this file, you'll see this file is different. So now we didn't have everything on one line because we've changed the way the file looks. And that's the way the file looks over here. But when we look at our VS Code, the file still looks the way it did. So the reason for that is we need to sync our branches. So these little circles here means that we should sync the changes. And when we click that, it will pull the online version to our local version. So now our file has been updated to look the way it does on GitHub. So now the next thing that we can do is we can use branching. So what branching does is it allows us to have two separate versions of the same file. So currently we are on the master branch. And general practice is that your master branch should always be a working version of your program. So if ever you're making changes or trying new things, always do that on a new branch. And then once they're working, merge it back into the master branch. So we're going to create a new branch called branch test in this case. And you'll see as soon as we've created the new branch, Visual Studio tells us that we are now on the branch test branch. If we type git status at this point, it's also going to tell us that we are on the branch test branch. So now we can make a change to the branch. And if we save this change now, it'll tell us that we have some changes. The file has been modified, and we are currently on the branch test branch. So we can add these changes, we can commit them. The message can be branch change. And now we have made a version of our file in this branch test branch. So now what we can do, so no, the only time that this file will be added to this branch is when we make a commit. Up until that point, this branch had nothing on it, and it says here that there's nothing to commit. So at that point in time, it's just an empty branch, and the branch will be identical to whichever branch it was made from. So in this case, the master branch. Okay, so now if we click branch test, we now have two branches. We have branch test and we have master branch. So if we check out the master branch by clicking on it, you'll see now that that line is not in the master branch. And then if we go and we check out the branch test again, it's got this line. So that's the power of branching, is that we can make lots of changes to our files. You can work on different features in your program at the same time. Lots of people can work on the same code base, because each of them works on their own branch and they keep track of their own changes. And then eventually when it gets to the point that you need to merge everything together, at that stage, you fix any problems that might arise. So now if we go look on GitHub, I'll just refresh this page, you'll see that we still only have a master branch at this stage. So that means that we haven't published our branch to GitHub. And the way we would do that is by clicking this little cloud. So this is the same as this step that we did earlier, where we did the git push upstream origin master. We could either type git push upstream origin branch test, or whatever I call this branch, or we can just click this cloud, and that will then push our changes online. So now that we've done that, if we refresh GitHub, you'll see that we have both of our branches on GitHub, and they will have the different changes depending which branch we're on. So now there are lots of other things that you could want to do here. I don't have time to cover these. So pull requests is how you merge branches together on GitHub. So generally my advice would be not to merge things locally, merge through pull requests. So what we could do is, just as a quick example, we can say compare and pull request. So this is saying compare branch test to master, and this says that it's able to merge. So there are no conflicts in this file that it can't figure out on its own. And then when we create a pull request, it will basically check whether we can merge these two branches together. We can then merge the pull request. And once they merge, you can delete that branch because it's now included in the master branch. So now if we go back to our repository, we only have a master branch, and the changes from the other branch are included in this branch. So this is a bit advanced, so I don't have time to really go in depth into what this is doing. There is a good Git book that will explain all of this, and GitHub has got great documentation explaining this. So read up on that if you need to use any of these types of features. The last thing that we can look at is in your settings, you can go to the, where is it? Oh no, it's Insights, sorry, wrong tab. We can go to the network, and the network gives us a high-level overview of what has happened in our project. So this was our initial commit that we created. We then made another commit with some small changes in it. We then made a branch. So now we have two versions of our code here. We have our branch change, and then we merged our branch change back into the master branch. And if you click on any of these dots, it will then show you what changes took place with this commit. So in this one, we deleted the second line of the file because we added the space. We then added it as the fourth line, and we added an extra line. So that is a high-level overview of Git. I recommend that you use it and get used to using it. It's extremely useful. It does have a fairly steep learning curve, but that just, I mean, after a while, you'll get used to it, and then you'll be able to manage all your projects. Okay. So now the next thing that we're going to cover in this presentation is basically the same things that we've just done, but how to do them all in the terminal. So If we were in the terminal, the first thing we would do is change directory to whichever directory we'd like to track. We would then initialize Git. So this was when we clicked that initialize button, it was actually running this git init command. The # over here just means that this is a bash command. Anything you enter should actually be just from Git. So don't include the $ if you ever enter any commands. I think that you can view diff files in Visual Studio. I have not done that, so it should be possible. Okay, so we can initialize a repository. We then add our untracked changes. So add with the dot will add all files to be tracked, or add all changes to the staging area. On the other hand, we can say git add with a singular file name or a list of file names, and this will add only those files to be tracked. Okay, yes, I think we will update the link to OneDrive in the URL that David posted at the beginning, because that is the old link. And yes, we're not using Slack for this course. We're using Stack Overflow, and OneDrive has got all the presentation PDFs. So once we have added our file, it's now been staged. The last step is to commit these files. So we would then use git commit with -m, meaning we'd like to add a message and whatever our message is. So all of these steps can be done in Visual Studio Code, and that's what we did most of the time. So generally, it's easier to just use Visual Studio Code. You should still have an idea on how to do this in the terminal in case you don't have Visual Studio Code or something breaks and you need to fix it manually. So this we have, so this is if you want to clone a repository. So the way that you clone a repository from GitHub is you need to find the URL. And the way you do this is you go to that project on GitHub, and if you look in the top right corner, there's this green button that says clone or download. If you click that, it will then give you the URL for this GitHub repository. Once again, I use SSH. Make sure you use HTTPS or set up SSH to work. And the next thing you would do is change directory to the folder that should hold the project, and then type git clone with this URL you copied, and that will then download all these project files into this folder for you. So these are just a few useful commands that you might want to use. The first is git status. What this does is it'll tell you which branch you're on. It'll tell you what files have been modified or what files are untracked. I think it'll also tell you what files are staged. It'll also tell you if the branch you are on is ahead or behind of the remote branch. If your branch is ahead of the remote branch, it means you have changes that aren't on GitHub. If it is behind, it means that there are changes on GitHub that you don't have. Git diff with the file name will show you what's changed to the file since the last commit. Git reset with the file name or a dot will, instead of adding a file, it will remove a file from the staging area. You will lose your chain. I'm not sure about that. You'd have to read up on that. I think that this is, later on, I've got another slide on this that explains it in more detail. Finally, git stash will temporarily save all your changes and change the files back to the way they looked like in the previous commit. So this is useful if you have made changes that don't warrant their own commit, but you need to download newer changes and things like that. So you'd first stash all your changes. You can then sync up your repositories, check out other repositories, make changes you need. And then once you need to carry on working again, you can then pop the changes out of the stash. So this will then just reapply the last changes back to the project that you're working on. VS Code would, so one directory is generally linked to one repository. It's not always the case, but that would be the sort of the way it worked. You can always link one repository to one project to multiple repositories, they just get different names. So I haven't actually got that yet. When we, oh wait, I can show you. When we did this step, we added a remote to our project called Origin. What you can do is you can add another remote called an Origin 2 or something with another direction, and then you can tell it whether to push and pull from different origins. This isn't very common to do though. Generally, one project will be associated to one Git repo. You wouldn't want to do it with multiple. And I don't know if that functionality is built in. I'm sure that you can tell it if we had to change branches, it's saying that this is on the origin master. If we had another origin, it would tell us origin 2 master and things like that. Yeah, so I mean, the way that this works, I do use this with multiple projects because each project that you work on has got its own Git folder, and this folder is linked to a repository. So whenever I open a project, it is linked to Git. So you use every project I work on has got its own Git repository. Okay, popping, right. So this is just some terminology on Git. So what a branch is it's a version of your files. You can have as many branches as you like. You can also use a slash in the branch naming to group your branches together. This certain programs, and I think GitHub as well, will automatically do this grouping for you so that everything's more organized. So these are just some common groups. There are way more than just these three. So if you are adding a feature, you say it's a feature with the / and the description of what your feature is. Work in progress, same thing. Or if you're fixing a bug, you would label this branch as a bug fix and then the description. What a remote is it's your online repository. Generally, the remote's going to be called Origin. So remote branches will start with Origin. So when you're listing all the branches, anything that says Origin with the / is on the remote, not on your local system. An example of that would be Origin / master and master. So your local master would be the one without Origin, and that'll generally point to the remote master. A commit is a snapshot of your files. And generally, this is a hierarchy you can think of. So you'll generally only have one repository. Each repository will have many branches, and each branch will have many commits. Your repository will generally have one remote. Each remote can have many branches, and each branch in the remote will be associated with one local branch and can have many commits. So think of the local branches and the remote branches as separate things that get joined together. Okay, so we had a look at this actually on GitHub. So if we have made a commit at this stage, we've made some changes and we've made another commit and we've made a third commit. And at this third commit, we now want to try something experimental. So maybe adding a new function to our program, it's going to break things to add this. So we want to make a new branch. So the way we would do that is by typing git branch with the branch name or using the VS Code shortcut. And this will then create our new branch. So at this stage, we have two different branches. Once we've created the branch, we check out that branch. This just tells Git which version of the files should be loaded. So creating a branch does not automatically check it out if you're doing it in the terminal. This would then change the current branch to be the new branch. If we type git branch, it will provide a list of all the branches that are available, and an asterisk will be next to the active branch that's currently being used, so the one that's checked out. And git status will give us some high-level overviews. So once we're on a branch, if we create commits, it will then start adding the commits to this branch, and master will remain unchanged. Once we are happy with all of our changes that we made, the next step is to merge. So this would take our separate branch and change master to look like our new topic. So something to remember if you ever do merging, you always merge into a branch. So you start by checking out the branch that you want to apply the changes to. In this case, it would be master. And then you type git merge and the name of the branch that you would like to merge the changes for. So this will then merge all the changes into the new branch. Something that can happen is you can get merge conflicts. So what conflicts are is there are two different versions of the file and it can't figure out which is the correct version to use. You then need to go to these one by one and say, for this change, use topic 1's version. For that change, use master's version, so on and so forth until you've gone through all the changes. I would recommend not using this though, and rather use pull requests on GitHub. That's just my workflow, and I find it works much better than merging locally. So GitHub is just the online place to store your files. So it just keeps track of your changes online, and it makes it much easier to share your code with collaborators. And it also offers a very good way of backing up your code, because generally it would be something really catastrophic if GitHub lost your files, because I'm sure they've got multiple backups of everything on GitHub. So the way we do this, we went over this earlier, is we'd create a new repository on GitHub using their menus. We would then link that repository. This is given to you once you created your repository. So it's just telling Git you would like to add a remote called origin, and that's the URL for the remote. Once you've done that, if you type git remote-b, it will list all your remote repositories for the current project. And then you can push your changes. So git push the name of the remote and the name of the branch. So git push origin master will push our master branch to origin. Okay, so Git and GitHub are different things. Git is the software that keeps track of changes, while GitHub is an online place where you can store your files. So they work together, but they are different. So Git is the actual version control tracking program, and GitHub is just an online repository where you can save your files, and it works with Git to keep track of all your versions. Something else, so then if we wanted to push, we can push our changes, and pull is the opposite of pushing. So we will pull the changes from upstream to our local branch. Another option is called fetch. I didn't add that here. So fetch will look if there are changes and not apply them. Pull will, if there are changes, will apply the changes that are upstream. Okay, so this is getting a bit detailed. I don't think I'm going to cover this. Just read over it. This is more advanced use of Git. So this is how to undo changes that you've made. Basically, to undo changes, you use reset. To look at previous changes, you use checkout. And if you have already pushed your changes online, it is no longer possible to use reset because this is only for local changes. You then need to revert. What this does is it doesn't delete anything. It just makes a new commit which contains previous changes. So Atlassian has got a good tutorial on all of these. I will post that somewhere. I think you can also look for it. So I've got the link here for Atlassian. They have got a tutorial on those topics, and they explain it in great detail with good visuals explaining exactly what's happening. So as I've said, most of what Git can do is available in VS Code. Sometimes though, things will break, and in that case, you are probably going to have to go to the terminal to fix that, because this has only got high-level commands that do basic functions. An example of something you can't fix is if you commit a directory containing things you shouldn't have, it is very difficult to remove it. You are going to have to go into the terminal to do things like that, to remove files from the Git history. Git Kraken is a program that manages repositories. I use this. I like it. Generally, I use VS Code more than this now. This was before I was using VS Code, I used this to do all of my Git, and I just use VS Code to do most of it. So one thing with Git Kraken is that you need to pay to use it. But what you can do is you can get a free license by signing up for the GitHub Student Developer Pack if you have got a student email address. So this gives you a whole bunch of tools that you would normally have to pay money for, and mostly it gives you about a year free for all of those tools. I recommend signing up for this. It is worth it. And then this is just some more detailed. So GitHub have got a lot of guides on using Git and the inner workings of GitHub. Atlassian is another, I think they make a product similar to GitHub, but they also have good Git tutorials. And finally, Git SCM is the Git, the book on how to use Git. It's freely available online, and this goes in depth how to use Git, how everything works. So generally, I would recommend looking at this book for some common features. If you run into issues, you can go look for more advanced topics on how to fix those. Okay, so before we get started, I have figured out what I think the best method is going to be to get the latest changes from GitHub for the project, for the course folder. So the way I'm deciding to do this is I made a branch with the changes. So you can just pull this branch with all the changes rather than making your own branches. And this way you shouldn't get any merge conflicts or anything like that. So there are 4 steps you'd need to do. The first is to add any changes you might have. You should probably do this to the master branch, but it doesn't really matter if it's not the master branch. Just add it to whichever branch is checked out at the moment. Once you've done that, add a commit message. So I'm doing this in the terminal. As I said, you can do all this in Visual Studio Code. The reason I chose to do it in the terminal is that I could have one visual which shows all the results you're going to get. Once we've committed our changes, we will fetch the new changes, and then we can check out lecture 3, because fetching will download lecture 3. So your shell might look slightly different from mine. Basically, you just want to look at what the command is. So git add dot won't say that anything changed. When we commit, it'll tell us whatever changes there were and they've been committed. I just did this as an example, so you will generally have far more changes than I did. Finally, if we say git fetch, it'll tell us that there's a new branch called lecture 3, and it's made a new branch locally called lecture 3, which will track the remote branch. And the last thing we can do is check out lecture 3. So at that stage, you should have all the latest changes for my lecture 3 slides on your local computer. And I think I can create a poll. Okay, I cannot create a poll. David, can you create a poll if you're there, just to see when everyone's finished doing this?
Yes, sorry. So let me, 1 second. So you want to see if everyone is up to date?
Yeah, they've updated their Git repositories. Something else that can mean if you get that git config is that you haven't set your git up correctly. So all you would need to do is type what they said there in the terminal. So git config -- global user.name, and in the quotation marks, just put your git username in there.
So does this like this?
Yeah, that's all I need, just so I can get. So just click yes once you are up to date. Oh, okay.
So there are lots of no's.
Yes.
Are you seeing it also?
Yeah, I'm seeing the result.
Okay, good. Yeah, I think it's because I made you co-host.
Yes. I don't think you can change your response though, so that's not, but yeah, okay, a lot of people.
No, but I can run it again.
Yeah, I think that would be a better option. Okay, so most people aren't there. So if in the chat, are you getting errors or yeah, so we can help you. Okay, so this question. You don't have to be in the master branch. I mean, you can be, so that doesn't really matter too much. Okay, no Git repository. Okay, so if you're getting that fatal not a Git repository, it means that you downloaded it and you didn't clone the repository. So that's what Toby was referring to. So in that case, yeah, if you get that message, it means that you've everything's set up correctly. And then as the final check, if you go to, I'm just going to quickly, sorry, I'll go back to the slide now. I'm just going to open the course repository. If you go to lecture 3, let's see. Once this starts up, it should say today's date as the date. That will mean that you've done it correctly. Yeah, okay. So if you're getting failed to push, I don't know why you would be getting that. Did you first link your, okay, so this isn't for the current course project. This would be if you're making your own Git repo. You would first need to link origin. So I would try git remote-v and make sure that that URL is correct before trying that. Yes, I can paste the Git link in the chat. Yeah, in terms of the error you're getting when you try to push upstream, did it give you more? It might have, how much if it gave you more information than that? Because that's not quite enough to debug it. Oh, yeah, sorry.
So Mark, do you want me to run it?
Oh, I saw that I can. Yeah.
Okay, great. Yeah, good.
Okay, so everyone who's got issues, are you getting errors or are you just following the steps still? Okay, so that error that you're getting means you need to clone the repository. So you would follow the steps earlier. So Control-Shift-P or Command-Shift-P to open the command palette, and then type git clone, and you would then paste the URL. If you've cloned, change the branch from master to lecture 3. So in the bottom left corner, click the branch that you're on and change it to the lecture 3 branch, because that's the branch that has the latest changes. So in the bottom corner here, it'll say lecture 3. If you're on master, this will not be the same, most likely. That is strange. Yeah, this is not the easiest thing to debug remotely. So try clicking the refresh button there. Okay, I'm just going to quickly go look at my repository online and see what that says. Okay, so on the master branch, this still is 2019. If we're on the lecture 3 branch, this is 2020. Okay, this is not so easy to fix. So for repository location, just pick somewhere on your computer, on the desktop, or somewhere that the folder should work. Okay, back to the slides. I've never seen that error before. So the ref spec is generally because the URL is incorrect.
Can I explain the ref spec real quick?
Yeah.
I was trying to get people to understand that they don't have to have us always reposting this URL to the Git file from the Git repository. So I posted the link to the GitHub repository, and on the GitHub repository, there's a green button that says clone or download. And when you click on that button for a Git repository, that will give you a URL that you can git clone. If you git clone the URL of the GitHub repo, like the one that was posted here with the invalid ref spec error, that points to the web page for that repo. So git clone will say, wow, this is an HTML file, but I'm looking for a Git file. And that's why you're getting that error.
Yeah, so it should end in .git, not just 2020. Okay, so I mean, that might be something else that you can try, is closing an open VS code. If you have changes to the 2019 file, it might not refresh automatically. I'm not too sure. This could be a Windows Mac difference. My files automatically refresh. It might not always be the case. But yeah, I'm going to carry on with the slides. Once again, there's not much that's changed compared to the previous. I just added the end of the lecture 2 to these slides. So that's pretty much the only change. But we've got 45 minutes, so there's quite a bit of stuff to get through in 45 minutes. So I'm just going to start with that now. So for the assignments for this course, they will go out on next week, Tuesday, and the following Tuesday we'll post a solution to the assignment. There will be in this assignments directory. These are the ones from last year. They're probably going to be the same. There might be some small differences just to make it slightly different from the previous time I gave these up. So yesterday, or not yes, on Tuesday, what we covered was some primitive Python objects. So these are just like at their lowest level, what can we represent in programs that Python will understand? In this case, it was numbers, strings, and we didn't quite get to Booleans. We did a little bit, so logical operators is what we're going to cover today. Variables, we did some basics with how to store our values so we can make changes down the line. We also looked a little bit at what PEP8 is and what reserved keywords are. We looked at some simple expressions, so 1 plus 2, and how you can assign the result of an expression to a variable, which is a statement. We also looked at a few miscellaneous things, such as mutability, and we also looked at how to comment our code. Today, we are going to look at compound statements. So using Boolean logic to tell whether some bits of code should run or not. We will look at how to get some input from our users. We will look at conditional execution, which is an extension of compound statements. And we will look at some common patterns of conditional execution. So before that, let's just break down the structure of a Python program. So this is some fairly in-depth things. So Python, at its most basic, is a sequence of valid Python statements. The way Python works is each line is a statement that does some task. Statements are split up into expressions, which is generally going to be on the right-hand side of your equal sign. And statements code. Statements, so like statements are what basically tell Python how to do this. So the hierarchy on how these all fit together is your complex Python program is made up of modules. Each module is made up of statements, which will be lines of code, and each statement has expressions within it. And you can read more on this over here. Just the main takeaway from this is statements are lines of code, expressions are A plus B is an expression that Python evaluates and then assigns the result to something, a variable, in this case, X. So the next section, what from last time, is compound statements. So these are called control flow statements or used in control flow statements, which are if-else statements, which allow our code to branch and do different things in different conditions. And they can also be used to control repetition. So do the same thing over and over again until some error tolerance is reached or something along those lines. So this will be covered at a late stage. Today, we're just going to look at branching operations. So in order for our branching to happen, we need conditions to be met. And the way that we meet these conditions is using logical operations. So these are all the logical operations. The first, we'll go through all of them one at a time. The first is a double equals. And what this means is it's doing a check to see if the value of X is equal to the value of Y. If the two values are the same, this will return true. If the values are different, this will return false. The next is not equals. So this is using a not in our expression. And, oh no, sorry. This is using the, instead of a double equals, it's an exclamation mark and an equals. This gets a bit confusing when you work in different programming languages because Pythons are sometimes different to other languages. So we'll just look at these. So not equal just checks if the value of X is not equal to the value of Y. Less than checks whether the value of X is less than the value of Y. Greater than just checks if X is greater than Y. Less than or equal to, greater than or equal to. And then the last one is the only one that's somewhat different. This is saying is X, Y. And what this means is it's looking if the variable X is pointing to the same block in memory as the variable Y. So it's not doing a value comparison. It's looking whether these two variables are referring to the same thing in behind the scenes in Python. So these are just some examples of all these operators. First, we assign two variables. So we set x to 5, we're setting y to 10. No, so x is equal to y and x is y are two different things. So when we say, let's think of an example for this. Okay, so if I say, I'm just going to copy this for now. And I'm going to set both of these to be the same value. And then I'm going to print x is equal to y. And I'm going to print x is y. Okay, so this is one thing of confusion, that this return true. This is an optimization in Python. So all numbers less than 256, I think, are optimized to always point to the same things. So if we make this number bigger, we're not going to run into that problem anymore. So in this case, when the first case, when we're going x equal to y, it's looking at the two values. So it's going, is 50,000 the same as 50,000? In the second case, it's going, is x, y? So it's saying wherever this 50,000 is stored in memory, is that the same location in memory that y is stored? And the way we can look at something like that is we can print the ID of x and the ID of y. So this is printing the two blocks in memory where these variables are stored, and is comparing these two numbers together. So in this case, they are two different numbers, so it's returning false. That's a fairly like detailed, that's like behind the scenes, it's quite low level understanding exactly what these things are doing. My general thing is you are most likely not going to need to use is, just know that it exists, use equals rather to do all of your comparisons. Okay, so in this case, all we're doing is we're printing first what comparison we're doing, and we're then printing the results of performing that comparison. So we're saying, is the value 5 equal to the value 10? This is saying false. Is the value 5 not equal to the value 10? This is returning true. Remember that not equals, okay, so this is one place where things get a bit different. My font automatically changes not equal into that symbol. So it is actually that symbol, it's not the not equal symbol. The next thing is x less than y. Yes, because 5 is less than 10. 5 is not greater, so that's false. 5 less than or equal to 10 is true. 5 greater than or equal to 10 is false. And then is 5 10 is going to return false because they're not referring to the same block of memory. And finally, if we check the type of one of these, it returns a Boolean. So anytime you do a logical operator, it's always going to return a Boolean, which is either false or true. So this is something like in Jupyter Notebook, these tables get formatted a lot better than they do in Visual Studio Code. So that's a bit unfortunate, but it's still showing the same topics. So there are 3 different ways you can join logical operators together: and, or, and not. So using these 3 in different combinations gives you different results. The first we look at here is the and operator. And what this does is it looks at the value of x and the value of y, and both of them need to be true for this to evaluate as true. So if both are false, this will return false. If only one of them is true, this will return false. But if both of them are true, it will return true. The or operator, on the other hand, will always return true if at least one of them is true. So if both are false, it will return false. If one of them is true, it will return true. If both of them are true, it will return true. So the last operator is called not, and what not does is it just returns the opposite of whatever it is. So if x is set to false, not x will be true. If x is set to true, not x will be false. So we can chain these together and do more advanced things, and that's what we're looking at here. This first example is looking at 2 different simple logical expressions. So the first is we are taking the remainder of n divided by 2, so n modulus 2, and we are seeing if it's 0. So this is checking, is the number even? And the second check is this number positive? So we are looking if n, the number stored in n is greater than 0. We can then chain these expressions together. So we can see whether the number is even and positive. So both of the conditions must hold. Or we can see whether the number is even or positive. So either the number is even or it's a positive number, it'll do something. So the way we do that is we have our expression. We then have the joiner, so the logical operator and then the other expression. So in this block of code here, we are setting n equal to 5. We are checking, so this is just printing what the number is. Let's make this 10. And let's just run this, and then we can go through it. So I don't know why I've got positive even here. I should have looked at my code. So we've got the number 10. We are then looking at our Boolean expressions. So just the two standard Boolean expressions. It's saying 10 mod 2 is even, or 10 is even, and that is returning true. And it's then looking, is 10 greater than 0? That is true. And then our logical expressions is the combination of these two. So is the number even and positive? Both of these are true, so this returns true. Is the number even or positive? Both of these are true, so that will return true. Now to get my formatting better, I'm just going to add an extra tab to that row, and I'm going to add an extra tab to this row so that these all line up with each other. So now on the other hand, if we say -5, well, let's make it an even number, -6. So now the number we're looking at is -6. And when we look at our expressions, is -6 even? Yes, it is. So that's evaluating to true. And we're going, is -6 positive? And it's not, because it's negative, so that's returning false. And then our logical operators, we are saying, is the number even and is the number positive? This is going to return false because the number is negative. On the other hand, if we say, is the number even or is the number positive, this will return true because it is an even number. So because this evaluates the true, this expression will evaluate the true. Right, so that is at its simplest the way that we can combine these expressions together to get complex like reactions from our code. So by making sure that a lot of criteria are met, we can say whether certain parts of our code should be run or not. The expression for doing that is going to be covered in the next step after this. So something that we also is very useful is getting user input. So this allows our programs to be dynamic. If we're not getting any input to our program, they will always do the same thing because there's nothing changing. By getting input, we can ask for numbers to be added together, which if we have time at the end of this lecture, we're going to make a calculator. They can also get input from command line arguments. This is something that we'll cover a bit later on. So this is when we're running Git, those are command line arguments to an extent from the terminal. So conda create -n, the -n and a name are all command line arguments. So we're giving input to our program from the command line. Something else we're going to cover is how to read data in from files. But for now, we're just going to look at input. So what input does is it will just prompt the user to input a value. And it's a pretty easy function to use. The way you use it is you just call the function input with the message you'd like to display, and you assign the result of that to a variable. So in this case, if we put this in and we run it, this is interesting. So the way Visual Studio handles input is it asks you in the command palette. If you're in Jupyter Notebook, it asks you underneath the box. So yeah, we can say hello, and if we push enter, hello was input. It was then saved into our variable to hold the input, and we then printed that variable, which is outputting hello. What is worth mentioning here is that the type of the input will always be a string. So it does not automatically typecast if you enter a number. So if we enter 5, it will not automatically change that into an integer. It will always be a string. And if we wanted to change this to an integer, we could typecast it using int. But you need to be careful when you're doing operations like this, because if you enter an integer, it will cast correctly. But if we enter something that's not an integer, we're going to get a value error. So generally, if you're getting user input before you typecast it, you'd first want to have a check to make sure that this type of value is correct before you tell it to become an integer. So we are running out of time. So in your own time, please just think about these questions. This is from last lecture, so you should be able to answer most of these. This one, you should think about a bit in depth, like why these are not the same. And this has to do with logical operations having their own order of operation. So parentheses are evaluated first. I think and has the next preference, then or, then not. So that's worth thinking about that and seeing how that works and going through it step by step and getting the final answer from these two trees. These are just some links for useful places that you can go to practice coding. HackerRank is a website that has lots of Python challenges. They have a good gradient from easy to difficult, and it will automatically grade your code to tell you whether you're doing it correctly or not. Code Combat is another place where it'll teach you to code. This is a game, so you have to give units commands to move around in Python. And I haven't looked at this in a while, but last time I looked, they went pretty in depth. I think they had everything up to writing web services. And so it's pretty cool that you can play a game and learn how to code at the same time. And I mentioned this in my slides. These are free tools you can get if you sign up for the GitHub developer pack. So the next type of code or the next operation we're going to look at is called the branching operation. So we can start with the image before we look at the description. So what this is basically we get to a point in our code where a decision has to be made. If this evaluates to true, it's going to run some other bits of code. If this evaluates to false, it's just going to carry on. So the only time these are going to get executed is if this condition evaluates to true. So this is called the branching operation, and in Python, it is an if statement. So this example we have here is if some expression evaluates to true, execute some statement block. And this is just a pictorial representation of what this code is saying. So in Python, indentation is used to separate code from blocks, so code in different blocks. So when you have an if statement, it ends in a colon. And after a colon, the next statement needs to be indented. And as long as this level of indentation is maintained, it'll continue to be inside this if expression. As soon as we start writing statements that align with the if, it'll be outside of our if expression. So this is an example of how that would work. We have our if expression with the colon. Statement 1 and statement 2 will only be executed if this evaluates to true. Statement 3 will always be executed. Whether this is true or not doesn't matter, because the next step after this branch is to run statement 3. So something to keep in mind, Python lets you use either tab characters or white spaces. The general rule is to use 4 white spaces, which is normally represented as a tab. Most people recommend using 4 white spaces. Down the line, when you start working with a formatter, it'll automatically convert all your tabs into white spaces or the other way around. So it's good setting things like that. The most important rule with doing these sorts of things is to be consistent. Don't mix tabs and spaces, because that can give you some errors and cause readability issues. Because what can happen is you can configure your environment to have tab represented as whatever you like. The default is 4, and I can set up VS Code to have my tab represent 5 spaces. So if you've got mixes, some things are going to be indented with 4 spaces, some things are going to be indented with 5 spaces, and it's probably going to break your code. So I think, let's see, if we copy paste this, I just want to make sure. So that is spaces. and that is also spaces. So the way my VS Code is set up is that it'll automatically expand tabs into spaces. So this example is not going to work because that'll always pass. But so if we run this, it's definitely going to work. If on the other hand, we make it 4 and 5 spaces, we're then going to receive an indentation error because it doesn't understand what we're trying to mean by having mixed indentations. If we make both lines 5, it will also still work. So once again, consistency is key. My recommendation will be use 4 spaces and you're not going to run into any issues. So as our first if statement, let's run this. So what this is doing is we are assigning some variable with the number. We are then looking to see if this number is bigger than 5. If this number is bigger than 5, we are printing large number. So if we run this, at the moment, 10 is bigger than 5, so this printed large number. If on the other hand, we set this to -10 and we run it, it now does not print anything because this condition does not pass, so this code is never executed. Okay, so there, that one had tabs for some reason. I do not know why. Okay. So now there are different patterns for branching. So this was at the most basic that you can get it. We just had one single branch to look at, and if that did not pass, code would just carry on normally. So another is called alternate execution. And what this means is we evaluate an expression, and if the expression holds true, we execute some statements, but if the expression fails, we execute different statements. Once this is finished, our code will just carry on as normal again. So this is a pictorial representation again. You get to your condition. If this evaluates to false, it will run statements 2. If this evaluates true, it'll run statements 1. So then we have an example of this. And if we run that, so what this is doing is it's asking us for input. We're doing typecasting here. So this would break if you try to enter a character because we're not doing any checks. And if the number is even, we are going to print that you entered an even number. If it's odd, it'll print that you entered an odd number. So as our number, let's enter 15. And I'm lost. Okay. So we entered 15, and this is telling us that we have entered an odd number. And if we did an even number, it would then, instead of this evaluate, would be true. So it would print you a printed even number. Currently, it is false. The third type of structure we can have is we can chain our tests together. So we can check a condition, and if that condition passes, it will execute one statement. If it fails, we can check another condition, and if that passes, we can print another statement, and if all of these fail, we can have a final statement that will always get printed. So in this case, we're first checking if x is less than y. If it is, it's going to execute statement A. If this evaluates to false, it's going to check whether x is greater than y. This will then print statements B. Finally, this case will only be reached if x and y are equal to each other. It will then print statement C. So this is a way that you can chain different if statements together. We can then print this. Okay, so what this is doing, once again, we're getting a number. We're then checking whether this is positive or 0 and even. We are then checking whether this is even and negative. And finally, we are checking if the number is odd. Okay, so I am getting a syntax error. This happened. Line 7. Line 7. Okay, so I'm missing a quotation mark at the end here, and that's why this wasn't working. If you want to get line numbers, you can push escape, and you'll see it'll go blue on the side here. And then if you push L, it will turn on your line numbers to turn them off. Okay, so if we run this, it's going to ask us for inputs. I'm going to say -20 and see what this says. So we entered an even negative number. So 20 evaluates to even, 20 evaluates to be negative. So that's why this got printed. Finally, you can nest conditionals together. So you can have if A is greater than B, do this statement. Otherwise, check if X is greater than Y, do that statement. Otherwise, print statement C. Something to remember is that this tree and this tree actually are doing the same thing. This is much easier to read. So generally, do not nest if statements within each other. You don't have to do it. If you think about your logic a bit better, you can normally have one level of if and not have to nest them. Something else, just performance-wise, down the line when you're writing code, if the most common check should always be your first check, so that it doesn't have to do a lot of checks before reaching the conclusion. So always try and list the order of your if statements in order that they are most likely to occur. Okay, so this is a more complicated example, and this is if we were doing some diagnostics. We have a disease case which can either the person has the disease or not. If the person doesn't have a disease, then they don't need to get a drug. Otherwise, we check some expression count, so another integer, and then due to the level of this expression, we either give them a drug A, a drug B, or a drug C. So if we run this block, the first thing we need to enter is whether they have the disease or not. So if we say 0, they don't have it, it doesn't need to check any of these. So it says no drug required. On the other hand, if we say 1, they do have the disease, it now asks for the expression count. So if we say they have 5 as the expression count, this checks whether the expression is between 0 and 4. This checks if it's 5 to 10, and this is anything negative or larger than 10. So this evaluates all those trees. Okay, so we have 8 minutes. I was going to build a calculator in Jupyter, the command line, and VS Code. Let's start doing this in Jupyter. So I'm just going to write this code quickly, and it's not very difficult code. And then once we've done this, we'll translate it from Jupyter into Python, and we'll run that in VS Code and the command line. So if we want to make a calculator, normally I'd stop for a while and like get us to think about what a calculator is, but I'm just going to explain it. So we would have 3 things. Firstly, we need 2 numbers, and we need an operator. Okay, so we're going to have to prompt the user for input for these. And for now, because we haven't really done any error checking, let's just assume that the user is always going to enter perfect input. So we can have num1 equal to input and enter number 1. And because we're assuming that the input's going to be perfect, we can cast this to be an integer. For now, let's make this a float rather, because otherwise our calculator would only handle integers. In this case, it should be able to handle both. So num2 is a float, and we are going to go input, enter number 2. And the final thing we're going to do is our operator, and this doesn't need to be typecast, so it can stay as a string. So we can have input and enter the operator. So now that we've got our numbers and our operator, if we run this block of code, so we enter our first number, our second number, and our operator, nothing happens because we're getting the input, but we're not doing anything with it at this stage. So what we want to do is the first way we would build this program, and later on you can do more advanced things, but for now, the way we would do this with our current skills is to use an if-else tree to figure out if we know the operator or not. So we can start with if the operator is a plus, then we're going to do something. So what parse does is Python needs an indentation after a colon. Parse just fills in that indentation so that if we ran this code, it would not break. So nothing happens still, but it doesn't give us an error. If, on the other hand, we didn't have parse over here, and we ran, we would then get a syntax error because it needs an indentation. So now we can fill in the rest of our operators. So elif is saying else if the operator is, let's go negative, false, and we can just copy paste this 4 times. So we're just going to do simple operations. So plus, minus, multiplication, and division. And the last thing we're going to have is an else, and this we can print unknown operator. Okay, so at this stage, if we run our program, we enter 2 numbers and a known operator, nothing will happen. If we run our program and we enter 2 numbers and something else, we run that, it's going to print the unknown operator. So don't use continue instead of pass. Continue has got another meaning, and that is used in looping. So we'll cover that in a few lectures time. Pass is just a placeholder. That's all it is. It just, you need to come back and fill these in. Continue, on the other hand, is telling something that's repeating to continue on and ignore everything after that statement. Okay, so for now, let's just add all our logic. Normally, I would make this more fancy and have x plus y equals, and let's just do it, num1 plus num2. I was going to ignore this just to make it faster, but it's not too much effort to do all this. So we can then copy this line and just replace all the other lines. And then just replace our operators with the correct operators. All right, and then just replace the output with the correct output for these operators. Multiplication and division. Okay, so now we've got our calculator set up. So what we're going to do is get 2 numbers from the user, cast those to floats so that they are numbers instead of strings. We then enter an operator. If it is either plus, minus, multiplication, or division for the operator, it will do the correct operation and print the result. Otherwise, it's going to tell the user that the operation is unknown. So our first number, we can go 5. For our second number, we can go 8. For our operator, let's enter multiplication. And then we have x plus y is equal to 40. So the last change I would make to this is, instead of having x's and y's, I would make this go num1, comma, with the plus, and this is going to need a bit more breaking down, num2, and equals. So I'm not going to do this for all of them for now. I'm just going to do it for the first one. So what this will do is it'll print the first number, it'll then print a plus, it'll then print the second number, it'll then print an equal, and it'll then print the result. So I'm just going to run this with the plus for now. So if I go 1 and 2 with plus, we now have 1 plus 2 is equal to 3, and they've all been typecast into floats. So generally, you always want your output to be easy to understand. So instead of having x and y, it doesn't make sense. We put the actual values in there so someone using our program sees what the logic is and what the result is. Now, the last thing we're going to do is make a Python script from this. That's pretty easy. In our my lecture 3 folder, I'm going to add a new file called calculator.py. And we can just copy paste this code directly into that file. So if we copy that, we can paste it in here. And now, instead of running in interactive mode, this is a Python file. And to run this file, we can just click this plus in the top corner, and that will run the Python file in the terminal. So the first thing it's asking us is to enter our first value. So we can go 5. For our second number, we can enter 7. For the operator, we can do multiplication, and that will complete. Once all our input has been processed, the program executes and we get the command line again. So something else that we can do is we can run this program actually from the terminal and not using Jupyter. So the way we would do that is you would type Python to tell the the computer to run Python, and then the path to the Python file. So in this case, we're telling Python to execute calculator.py. This asks us for our first number, our second number, our operator. And the reason that this gave an error, I think, okay, so one reason that this might be happening is if I type Python now, this is running Python 2. So there are big differences between Python 2 and Python 3. So I'd first want to activate my ITP 2020 environment and try this again. So that error we were getting was because Python 2 and Python 3 work differently. So the syntax we used for our Python 3 code is not the same as Python 2 syntax. And for that reason, we got an error. All right, so those are the different ways we can run a Python script. It's 2:30 now, so I'm going to stop here. Write your own calculator, get it working. Once again, if you get any errors, ask questions in Stack Overflow, and I'll get back to you and give you help you with any issues you run into. Thanks.